Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating system. This is for the students studying in the 5th semester of their BSc degree program. So this is of paper 8 in their 5th semester. So in today's session we are going to learn topics on unit 1. So the unit 1 comprises of many different topics, out of which in this session we are going to see topics on the process management, about the process and the different types of process, the process features and the process scheduling and their process control blocks. Now in today's session we will be seeing the contents are the process concept, what is a process, what are its features of the process, what is a process state, what are the different process states available, and what is a process control block, what are the contents available inside this process control block, what is process scheduling, what are different types of schedulers, and then about a context switch. Now what is a process? A process is a program in execution in a sequential fashion. So say for example, if you are going to have, you might be knowing the difference between a project, process and a product. A project is something like a plan or proposal. A product is an end result, a deliverable. So a process is nothing but it is how you are going to achieve your end result based on the project. So that is a process in general. So as far as an operating system is concerned, what a process is? A process is a program in execution in a sequential fashion. You call it as a process. So here in this, a program in execution which forms as a basis of all the computation for your regular workings. So what does this process consist of? The process consists of a program counter, a stack and a data selection. So what is a program code inside a process? A program code is also called as a text section. See, a process is nothing but a program, an execution of program in a sequential fashion. So in the execution of program you have the program codes. A program code is nothing but a text section. So under this, what are things we have? We have a stack which stores the temporary values. Then we have a data selection, so wherein all your data have been stored. So we will see here a process contains the program code which is also called as a text section, a program counter, a process register and the stack. The stack contains temporary data. Temporary data is nothing but we have the functional parameters, return addresses and the local variables. And then we have a data section. The data section contains the global variables as well. The heap contains the memory. Then what is a program? A program is a passive entity, whereas a process is an active entity. So what do you mean by a passive entity and an active entity? A passive entity is one wherein you have coded things, whereas a process is one which you are going to work for the program, which makes the program to work is called as a process. Then we will be seeing the different sets of process states. What are the process states? A process is an execution. This execution can take place in various states. The first state is called as a new state, then we have a ready state, then we have a waiting state, then we have a running state, then we have a terminated or the exit state. So now what is a new state? A new state is one wherein you have the new process has been created. Here in this, the process executes, it changes states: a new state, running state, waiting state, ready state and terminated state. A new state is one where a new process has been created. A running state is one where the instructions are being executed with the help of a process. So in the program, the instructions have been executed is called as a running state. A waiting state is one wherein this process is waiting for some event to occur. Say for example, supposing if a resource has been allocated by some other process, then this process has to be kept in the wait mode. Or supposing the process has been interrupted by one other process, then till that other process, which if the other process comes with a higher priority, then definitely this process will be put on hold. Then this process which is under execution will be interrupted and it will be put on hold. So in that situation, till the other process which comes with a higher priority gets completed, till that period this process will be waiting state. So that is called as a waiting state. Next state is called as a ready state. A ready state is a process is waiting to be assigned to a processor. So if it is in a ready state, then definitely your work, the set of instructions will be put on the main memory, so which is ready for execution. Then the last state is called as a terminated state. A terminated state is one wherein we are going to exit, or if a process has finished its execution. So that is called as a terminated state. So let us see this on a diagrammatic basis. So here it is a new state. This is a process diagram. This is a new state wherein a new process has been created. Now this process, the instructions will get loaded into a main memory. So it comes to a ready state. So which means that it is getting admitted. Then after getting admitted, it goes into a ready state. It has to get executed. So it goes to a running state. Supposing if some other process comes by chance with a higher priority, then it goes to an interrupt state. So this execution will get stopped and again it will move on to an ready state. So this is nothing but an interrupt happens and it again goes to a ready state until the new process gets completed. Then supposing if the other process gets completed, then it again goes to a running state. Then till that period, if some other resource has been executed by the other process, then it has to wait. So it goes to a waiting state. So resource means in the sense the IO devices. IO devices is nothing but the input and output devices. Say for example, if the other process is executing is using the printer resource. So this process also wants to use the printer resource. So till the other process gets uses the printer resource, until all the printing works of the other process gets completed, this process has to wait. So that kind of state is called as a waiting state. So when it goes to a waiting state, again it will go to a ready state and then it will come back to a running state. So here after running it goes to a waiting state, and after waiting it goes to a ready state in the IO or event completion, and then from this it again goes to a running state. So after this process gets completed, it goes to an exit state or the terminated state, which means the process has got completed. That is called as a terminated state. Then next is about the process control block. What is a process control block? So what are things that you are going to do within this particular process? How this process is going to get executed? That's called as a process control block. So what are things you need to have for executing this particular process? The contents is called as a process control block. So in this process control block, you have the following contents. One is the process state, other one is the program counter, other one is the CPU register. CPU is nothing but central processing unit. Central processing unit registers, CPU scheduling informations, memory management information, accounting information, and input output status information. In this accounting information is nothing but what are the different sets of files and folders that are available for which are ready for execution, and here even what are the files that are ready to be in use. And input output status information is what sort of input output devices or what sort of input output status are necessary. Those details are required or noted down in this process control block. So this process control block looks like this. Here, wherein you have a process state, a process number, the program counter. So each and every process state is nothing but, as I said, you have different set of states like new state, ready state, running state, waiting state, or the exit state or the terminated state. So each and every process has a unique process number. So that process number will be stored over here. Then you have a program counter. A program counter is one wherein each and every set of execution will be having a counter value. So how many number of times the iteration has taken place will be stored in this program counter. Then you have the registers as general purpose registers, special purpose registers. Then you have the memory limits. Memory limit is how much of memory is required for executing this particular process is called as a memory limit. Then what are the files that are kept in open? That is nothing but list of open files. And what are the input and output devices that are required for executing this particular process is being stored over here. So this is a process control block. Then now we will see how a CPU executes or switches from one process to the other process. Supposing if a higher priority process comes in, as I said earlier, supposing if a higher priority process comes in, how this process gets interrupted and how the execution is used for the other process and how the other process completes, and then how this particular process gets completed its execution, which we will be saying it on a diagrammatic basis. So here let us consider this is said to be process P0, this is process P1, and we have an operating system. So now at first we will start executing process P0. So when we start executing the process P0, whatever we do when we start itself, we are supposed to save it in the PCB. PCB is the process control block. So we are saving the state in the process control block, and that numbering is 0. So immediately and it has been saved and it is in execution. So what happens is that till one particular period, this process P1 is in an idle state. So supposing if this process P1 is said to be in a higher priority, so it gets reloaded. So we get an interrupt call. So till this process P1 executes, this process P0 comes to an idle state or it comes to an waiting state. Then this P1 after execution, all these details gets saved in the PCB. So that PCB is numbered as PCB1. PCB is a process control block 1. Then again this process gets reloaded, the process 0. So now this process P1 got executed, so it got completed. So after execution it goes to an idle state. So then this process P0, it again comes into picture from the saved one, from PCB0. It has been saved in a state called PCB0. So that PCB0 is being reloaded and it starts its execution. So this is how a CPU switch takes place from one process to the other. Next is we will see about CPU scheduling. What do you mean by CPU scheduling? A CPU scheduling is one, the central processing unit, it schedules the process. So how does it schedule the process? So what sort of how much of time it should allocate for one particular process to get completed, and how much of effort is required, and what are the devices that are required. So all these things will be taken care by this CPU scheduling, and this scheduler will be allocated by this operating system by and large. So what are the CPU scheduling algorithms that are available, or how it is being done? We will be seeing what is a CPU scheduling. So we will continue the CPU scheduling after a small break. Welcome back. We were seeing earlier before the break, we are seeing topic on the process, about the process and how a process has been scheduled. So now we will continue with the same. So this process has been scheduled by the CPU. So as far as the process scheduling is concerned, you have different queues. Scheduling is nothing but it is going to allocate certain time limit for a particular process to get executed. That is called as scheduling. So how it has been scheduled, what are the queues that are available within a CPU, that we will see now. So there are different sets of queues available. One is called as a job queue, second one is the ready queue, third one is the device queue. So what is a job queue? Job queue is set of all processes in the system is called as a job queue. What is a ready queue? I said in the before the break, I said when a process is said to be in a ready queue, then it has to be placed in the main memory. So set of all processes residing in the main memory which is ready for execution is called as a ready queue. Then what is a device queue? A device queue is a set of processes that are waiting for an IO device. What is IO device? IO device is an input and output device. So output device is something like, supposing a process is waiting for printer, then that particular process, that particular line of execution, program in execution will be placed in the device queue. So that is a device queue. So these are the queues that are available in the process. Then now let us see what a fork is. What is a fork system called? What do you mean by fork? A fork is one which is used to create the processes. Okay, where is a fork used? Usually a fork is used in order to create a child process. Okay, what do you mean by a child process? Why do you need to create a child process, or what does a child process do? Now what is a fork? This child process, if it has been created, usually what does a child do? It will see what its parent is doing. In literal terms, what does a child do? It will see what a parent does. So it will be doing all the activities whatever the parent does. That is, it will inherit the properties of the parent. So that is one thing. Or the child will be a subset of a parent. It cannot be more than a parent. It will be a subset of the parent, at least in the initial stages. So that is we will compare this example into a fork or creation of a child with respect to an operating system process management. Here a child, supposing the fork system call gives a value of a negative value. There are three types of values possible of a fork system call. Supposing if it gives a negative value, then that child creation is not successful. Supposing if the fork system call gives a 0, then it means that a child has been created. Supposing if it gives a positive value, then it means that a child has been created, inherits the property of the parent. And in Unix operating system, it is so common that you will be the child process, the child fork will be allocated a separate address space in the memory as that of a parent. But that is not so common with respect to the other operating systems. So these are the three types of values wherein this fork could give. So here it is. If the fork returns a negative value, the creation of a child process was unsuccessful. The fork returns 0, it means that it has created a new child process. If the fork returns a positive value, the process ID of the child process to the parent. So usually the process ID will be an integer. So now we will see this on a diagrammatic basis. Here it is, the representation of a process scheduling. Now it is in the ready queue state. What is a ready queue state? If the process is in ready queue state, then all the details will be stored in the main memory. So it goes to a CPU. Then in the CPU, it checks for the IO request. If it is in the IO request, if the IO request is there, then it goes to a IO queue, which is nothing but the device queue, which we have seen earlier. So this device queue After being in the queue, if it is the time for the process to get executed, then it goes to the IO. After execution, again it goes to the ready queue. Then from the ready queue, it goes to the next level time slice. In the time slice, supposing the time slice gets expired, if you are not using it for a longer run, say for example, if you want to book an IRCTC, if you want to book a railway ticket, if you are not going to use the system for a pretty long time, then you may get an information that your session has been logged out. That is called as a time slice. That is for each and every user, a specific time has been given. So even in the case of banking online transactions, if you have been keeping your web page idle for a pretty longer time, your time gets expired out, and it says that there is session has expired. So that is called as a time slice. Time slice is nothing but allocating a specific time for executing one particular job is called as a time slice. Then if it happens to be into a time slice expiration, then it again goes to a ready queue, and from the ready queue again it goes to CPU, and then the example continues. Then it is to fork a child. Fork a child is again a smaller child gets created. So this child executes, then goes to a ready queue. Then if everything, and if there is a higher process, if a higher prioritized process comes into effect, then it goes to a interrupt state. So after this an interrupt occurs. So till that process gets completed, this interrupt will be there, and then it has to be waiting in the ready queue. Then it will be in the ready queue till that particular higher prioritized process completed. After that it goes to a CPU, and this process continues. So now we will be seeing about the schedulers. What are the different types of schedulers that are available? How this CPU schedules? There are mainly the schedulers are classified into two different types. One is called as a long-term scheduler, other one is a short-term scheduler. What is a long-term scheduler and the other one is a short-term scheduler, we'll see. We even have one other scheduler called as a medium-term scheduler. We will see how the medium-term scheduler works in a diagrammatic fashion. So now, what is a long-term scheduler? A long-term scheduler is a job scheduler which will be useful to select the processes that should be brought into a ready queue. A short-term scheduler is called as a CPU scheduler. A CPU scheduler is which process should be executed next and allocate CPU. The long-term scheduler, it usually takes 1 millisecond to execute, or even it takes from seconds to minutes to execute. Whereas in the case of short-term scheduler, it takes a very short period for execution, like in terms of microsecond. So here it is. This short-term scheduler is invoked very frequently in terms of milliseconds. That is very fast. It can be of milliseconds or it can even be of microseconds, short-term schedulers. Whereas in terms of long-term scheduler, it can be of milliseconds, maybe a long-term scheduler, or in terms of seconds or minutes is also a long-term scheduler. That is, the execution of long-term scheduler is pretty slow when compared to a short-term scheduler. A long-term scheduler is used to control the degree of multiprogramming. What is a multiprogramming? A multiprogramming is one wherein two or more number of programs get executed at a single instance of time. That is called as a multiprogramming. In the case of multiprogramming, we go in for a long-term scheduler, and this is effective. This has been proved effective in terms of controlling the multiprogramming sessions. Then about this processors. This schedule has the processes which has been classified into two groups. One is called as an IO bound process, other one is the CPU bound process. What is the IO bound process? This IO bound process spends more time doing the IO than computation. IO is the input output devices than the computations. Whereas the CPU bound process spends more time doing the computation. More time was been spent on doing the arithmetic operations, all sort of computing activities. Whereas in the case of IO bound, it is used for doing this kind of device oriented, for waiting in the device and for execution being carried out with the help of the devices is called as an IO bound process. Then what is a medium term scheduler? Here it is. this in the terms of medium term scheduling, it has a partially executed swapped out processes. So initially we have the queue, it has been put on the process has been put on the ready queue. In the ready queue, it goes to a CPU. From the CPU, what happened is that as for the medium term scheduler, so it swaps out and the swapped out processes are been put on to a ready queue again. So it waits in the queue and it goes to an end. So this is an intermediate between a short term scheduler and a long term scheduler. So that is called as a medium term scheduler. Now the next topic is about the context switch. What do you mean by context switch? That is switching from one process to the other process, switching from one context to the other context when during execution is called as a context switch. So here when the CPU switches to another process, the system must save the state of the old process. Where does it save the state? It saves the state in the PCB, as we have seen in the earlier example. So and it also gives a number for the PCB. We have seen an example with respect to PCB 0, PCB 1, so on and so forth. So it must save the state of the old process and load the saved state for the new process via a context switch. A context of a process is represented in the PCB. Then a context switch is one which is said to be an overhead. Overhead in the sense is that as it does not do any sort of useful jobs when it is switching from one context to the other. So here it is. The more complex the OS and the PCB, the longer the context switches, and this context switches time dependent on a hardware support. So some hardwares provide multiple set of registers per CPU and multiple contexts are loaded at once. So this is about a context switch. Now let us summarize what are things we have seen so far in this session. So we have seen about what a process is. A process is, we have learnt about what a process is. What is a process, and then what is a, here even this process is sometimes even it is referred to as a job. In our previous sessions we have seen about different sets of jobs, something like a batch job, online job, real time jobs. So all these jobs are been is nothing but it is a process, it is a program in execution. So we have seen about the process and the different features of a process. What are the features of a process, or what does the process contain by and large? So it contains a program code. A program code is otherwise called as a text section. Then we have as well seen the about the after program code, it contains a program counter. So what does the program counter contains? It contains the numberings, or how many times the program gets executed, the number of instructions. And then we saw about the what are things, what else the feature contains? It has the stack. Stack contains the temporary data. What is a temporary data? Apart from temporary data, it has the parameters. Parameters are the attributes or the values for, or the variables used for storing. Then we saw about the process control block. So what are the components that are available inside a process control block? What are the different components that are available inside the process control block? We also saw about the structure of a process control block, and then where the process gets stored when it is kept on a ready queue. Then we have learnt about the different sets of process states. We have learnt about the new state, the ready state, the running state, the waiting state, and the terminated state. So there are 5 different process states. And then we have learnt about how a process is being scheduled. As well, we have seen the usage of a context switch. Let us see the possible questions for this particular session. One is, what is a process? Second, mention the features of process. Third, list the different process states. Fourth, draw the structure of a process control block. Fifth, what does the process control block contain? Sixth, what is a process scheduling? 7, what is a process context switch? So with this we conclude this session, and we will see more about this process concept in the forthcoming sessions. Thank you.